and share my screen. Before I share my screen, I just want to let everyone know, make sure you take your quiz chapter 4 today by 8 p.m. And let's go ahead and get started. Recording's already started, and let's share my screen. Share application, share screen. All right. According to the syllabus, today is the 23rd. You have a quiz over chapter 4 that you should take. We're going to go over chapter 5. And your lab 2 is due by the end of the day today, 11:59. And we're going to go over lab 3. So let's go ahead and get started with chapter 5. Before we get started with chapter 5, covers 3 main topics. Can everyone see the Visual Studio clear?
Yeah, I can see it.
Okay, thank you. Let me go 200. Chapter 5 talks about looping, increment decrementing, and file processing. So we'll go over file processing using the slides, but right now I just want to go over the high level of the idea of looping. For example, in the code, if you have statements 1, 2, and 3, and you want them to be repeated, the way we would do it now would be copy and paste. Copy and pasting them and repeating them over and over and over again how many times we need. That is not an efficient way to do repetitions because the repetitions might vary depending on certain conditions. So the way we do it is we introduce 3 types of looping mechanism. A looping mechanism allow certain blocks of code, emphasis, I'm going to say blocks because we talked about scoping, blocks of code to be repeated over and over again and while a certain condition is true. We have 3 types of blocks that we will talk about. The while block, the do while, and the for. These are in the same language with C, C++, and Java, and some other languages as well. A while loop is a pre-check loop, which says, take this, right now. Is a pre-check loop that checks the condition first. If while is true, these statements 1 and 2 are going to constantly be executed until this becomes false. If you do not have these brackets, this scope thing, and you put true, same thing with the if, the only question or statement is statement 1. Statement 2 would never be executed in this case because while is equal to true, it'll keep looping statement 1 only. If you want to use multiple statements, always put them in a block. So this is a while loop check that checks the conditional first, and if it's true, execute the statements in the block until this eventually becomes false. This needs to become false at some time. The condition, and we're going to talk about different ways of the condition being true and false, and if you want to break out early, we're going to discuss that. This is a pre-check loop. So the minimal times this can execute would be what? What's the minimal amount of times that this loop potentially could be executed?
Twice.
0. Because if this is false, it's never going to execute. Because it's a pre-check loop. It says, hey, check the condition first, this condition first. If it's true, keep going. At some point, it's going to be false. So the max amount of times it could potentially execute would be infinity. So if this condition never breaks, we never exit out, this loop can go on indefinitely. Everyone understand the pre-check loop of a while loop?
Yeah. Yep.
Yes?
Wait,
Yes.
so it only checks it once when it comes down to the code and never
No.
after that? Or does it always check it?
It always checks it. On this case, it will execute statement 1, statement 2, and then validate the while loop again. Then go down, statement 2, 1 and 2. Eventually, if it breaks, if this becomes false, it will bomb out and go outside. But it checks it after each loop, after each iteration, it checks the condition. Clear?
Yeah.
It's a pre-check. The next one that we have is the do while. Notice where the difference between the while and the do while. This is what we call a PostCheck. Notice where the iteration, the check is. So it's going to go through all this at least once, check it. If it's true, go back and redo the statements. Eventually, this should be false and it would bomb out, but it's always going to execute at least once. It's the only post-check loop that we have. So with that being said, what is the minimal times this can be executed?
I think
Once?
At least once, correct? And the same thing with the max, it could be going infinity, keep going until this is true. So we have to find some logic to break this out. The next one that we have is a for loop. It has 3 parts. These parts do not necessarily need to be in this in a nice formatted way. They could be just put out somewhere else. You know, this NX could be outside this for statement, but you still need to have these semicolons. For loops is a pre-check, and it's used more when you know how many times a loop should be executed. The do while and do while, you continually go until a statement is false. A for loop is the purpose is to say, hey, I have 10 elements. I need to iterate this through 10 elements. So that's what the for loop is for. You'll see a lot of this when you go into chapter 7 arrays. But you will use this mostly when you know the size is finite. I know how many times I'm going to go through it. Because here's your counter, what you initialize with, your condition that you would want, and the update, which will eventually make this false. You can substitute a while statement and a for statement because they're both pre-checks, but this is when you know the indefinite, know many times you want to go through it. And you're probably using this one a lot in your labs. I'm coming. And we'll talk about this in more in depth, but it's a pre-check. So it checks this condition. It's going to initialize this variable. If there's any initialization, it doesn't necessarily need to be initialized. You can initialize it outside. And we'll talk about scope in that case. If you do it outside, you will need to remove it from here. You still need these separated divisions as in the update and the increment. Same thing, blocks of code. Any questions so far? These are the 3 looping mechanisms we're going to talk about.
Yeah, I have a question about does C++, just like TypeScript and JavaScript, does it have for of loops?
For of?
For of loops or for in loops like TypeScript and JavaScript have it?
That I can't speak about JavaScript because I don't need to see it. They have, Java has an enhanced for loop that you don't have to use all these parts. And we'll see that in chapter 7.
I think for of is it's just for iterating. It's also an iteration tool like while and for, like what you were just.
Yeah, you can, and then with lists and so forth, you can put your array right here, your index variable right here, and then this one could be your actual array, and so that way it loops through it. So it's kind of like a for each right here, so you don't have to be concerned. Just like with Angular, Angular has, I think, for each. So that's closely related to what you probably would say for each one of those, because these are the enhanced parts. And you'll see that in chapter 7.
Right.
Java has it as well. C++ has it. C, I never saw this in C. I think it was mostly in C++, but I haven't compared it with C. But this is the enhanced for loop where you don't need all those 3 parts, and this would be like a for each where you don't have to have, let's say, an index variable to make sure you don't break it, and it knows how many elements it has. So this would be like the for each.
Alright.
The way we sometimes increment variables, like I saw before with the x++, let me delete this. There are 2 types of mechanisms that we are going to increment, the pre-increment and the pre-decrement. All this says is this, take x and assign it to 1. Or it could say, if it's the other one, take the value of x, I'll do the shorthand notation of it, subtract it by 1. That is all. Same thing for pre and post, but be very careful on the way you handle them. They both do the add 1 or subtract 1, but it depends on what else is on the line. For example, if integer x, let's say, is equal to 10, I do a cout. What do you think will be displayed here?
10.
10. Now if I do a cout, and I do an x pre x, what is x going to be displayed here now?
Would it be 11 or not?
11. So I'm adding 1 to it. Cout, if I have now minus minus x, and I do cout x, what is it?
It's 9.
What?
9.
No, we're already at 11.
Oh, 10.
10.
Yeah. Okay.
But now what happens if I do this? Cout plus x plus plus. What's going to print out here?
Would that also be 11?
No.
Oh.
This is a post increment, which means execute this line as is with the current value I have now. So it's going to display 10. But after that line is executed, now x is 11. So now if I do cout now, x will be 11. Does that make sense?
So does this mean that for the post increment, no, not the post, the pre-increment, then it would work if you did the pre-increment on that line?
If we did right now, C out right now, X pre-increment, what would display here?
12.
12. When it's pre, it says, increment me first before you evaluate the line. Make sense? If the pre or post is on the line by itself, nothing else on the line, whether it's pre or post, they are treated the same. Nothing else there. Nothing else on the line. Then they're treated the same. However, when you have, let's say X is now 12. So now if I have integer Y is equal to XX minus, no, I'm sorry, XX minus this way. See out, what is Y? Right now, X is 12 at this point. Just keep it as X is 12 at the point. So what would Y display?
Wouldn't it display 11?
No,
No, 12.
12. Because it says, remember I says, if it's post, it says evaluate this line and then decrement me. So in this case, X is 12, so Y is 12, but if I do C out X, what is now X?
11.
11. So that gets very confusing when students start writing their loops, and then they use X plus plus greater than 10 compared to plus plus X. Because it says increment X first and then do the equality check. The other one says, okay, now do the equality check first, and then increment X. See the difference? I'm not going to do the same thing for a decrement because it's just the same concept, but it's just -1. But you see the difference, how it's handled. If it's all on the same line, by itself, it's treated the same. But when you put it with other values on the same line, it handles differently. So if you do plus plus, the first operator that's going to be evaluated is going to be the greater than. X greater than 10, and then it's going to increment X. In this case, if it's reversed, the first operator to be executed is the plus plus to increment X first before the equality. Any questions on that? So you can see the kind of questions that will be asked to make sure you can understand them. Same line, they're treated the same. But when you put them on the same line with something else, you have to be careful on the order of operations and whether it's pre or post. With that being said, let's start looking at the slides. We only have one other topic to discuss, and we'll discuss that with file processing when you come through it. Oh, this is chapter 4. Chapter 5. For those who have questions, please just chime in because I don't see the messages. Slideshow. Play from start. Chapter 5 is an introduction to loops and file processing. This is what we just talked about at a high level, but just now in PowerPoint slide form. The increment and decrement operator is the plus is the increment operator. It adds 1. And here's the shortcuts for it. Val plus right there is a post increment. It's the same thing of saying add 1 to me. And in reverse, you have the decrement, which is saying subtract 1. And to emphasize this, it can only be used with variables. It has to have a memory address. So here's an example. Int number 4, then they post it, do a post increment, and this is what I showed you before. It increments. But the thing is, this post increment and this pre-increment, they're on a line all by themselves. Nothing else is on it. So they are treated the same. And so this was kind of a bad example where they show you add 1 and subtract 1. It works the same, except if some other conditions are on the line. An if statement, a while statement, a cout statement, whatever it is, if it's post, evaluate that line with the value of that variable as is. After that is executed and it's a post, you increment or decrement as it calls for. If it's pre-increment or decrement that variable first and then evaluate the line. Pre-input, increment and decrement operators can be used to complex statements. When I used them in that while statement a moment ago, that's what they call a complex statement. It has more than one statement, more statements in it. In a prefix mode, the operator increments or decrements the return value of the variable. It increments and decrements and then evaluates the line. In a post mode, you do the statements first and then increment and decrement. That's all that this is trying to say. Here's what we just talked about. In cout val is 12. When you post increment right now, it displays 12. But on the after that line is executed, val is now 13. When it's a pre-increment on the cout statement, it increments the value first, which is now 14, and displays it. And right now, if it's a pre-increment, it decrements val, which is now 13, and assigns that to num. So num is 13 and val is 13. But when you do the post, num is 13, but then after the line is executed, val is 12, but num is still 13. We don't change num, but we only change val. Can be used in complex expressions, but be careful of the result. Like result assignment num plus plus in addition to minus minus num2. In this case, the current value of num, whatever it is used is adding to the pre-decrement of num2. So it all matters on what you want to do and make sure you understand it. If it's post, evaluate first, then increment. If it's a pre, do increment and decrement, and then evaluate the line. So this right here on num1 and num2, you can increment num1 and num2, but the summation of num1 and num2 does not have a memory address. It's in RAM, but it doesn't have a physical memory address as in num1 and num2 do. But so you can't increment this. After you apply num1 plus num2 to result, you later on then can increment results, but you can't increment a summation because it doesn't have a memory address. Can be used in relationship expressions. increment num1 and greater than limit of 2. Remember, this is a pre, so it increments first before it does this. So remember, order of operations, this is pre, so do it first and then this, but if this is post, it's going to do this first and then num. Introduction to loops. A loop is a control structure that causes a statement to repeat over and over and over again until a set of until the expression is false. This is where it would keep on going. If you need to do more than one statements, make sure you enclose them in these curly braces. Remember, like we talked about in last chapter, you can add variables to these scope of these parentheses in this block. Remember, the life of that variable is only within that block. Here's it. It's true. If this is true, the statements get executed. If it's false, it will not get executed. But when you write this and it's true, you eventually want this expression to eventually be false, otherwise we're known to be in an infinite loop. Here's the syntax that we do with the flowchart. It's very similar to what we did before in our labs. If the variable is less than or equal to 0, the expression, if it's true, you keep going this cycle. Eventually it's going to be false, then we exit out. For example, right here, while num is less than or equal to 5, cout is hello. It increments number. So each time this is incremented, we go 1, 2, 3, 4, 5. Then it goes to 6. 6 is less than or equal to 5. It fails. It exits this loop and goes out to that is all. This is what we call a test expression, and if it's true, it will keep executing this loop. Eventually, this number less than or equal to 5 becomes false, and it exits. And I'll show you in more details 2 other ways of exiting a loop, but we'll talk about those shortly. So right here is number is less than or equal to 5, print hello, add number to 1, you're looping. Each time you write in the flowchart, this kind of helps you out because this is your check mark. Because if you don't have this, this part condition would never be true, never be false, so you would have your infinite loop. So sometimes it's good to put in your blocks like we did before when you do our labs. Each statement that you need to do, put in a block so you have your checklist to say, hey, here's my condition, here's what I want to do, here's what eventually is going to make my condition false, so I can exit out. Usually when you go through a loop, you only want one way in and one way out. That's usually best practice. Not all the cases, there are some exceptions, but usually you don't want your code to become spaghetti where it exits out multiple ways. You always want to have one way in, one way out. The expression is evaluated before the loop is executed. The following loop will never be executed. Remember, this is a pre-check. So that's why I always says, what's the min and max? Min in this case will be 0 because this is false to begin with. So it would never be executed. So the min types of this could be 0. But like we did before the other one, if number right here, plus plus, was never here on line 12, that was removed, you would have this as an infinite loop. It would never get out, so you would see in your program going, hello, 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 and it'll keep scrolling. So you would almost have to do a Control-C or Control-Alt-Delete and exit your code. This is what we just talked about. The loop must contain code to make the expression become false. Otherwise, the loop will never end, and that's what we call an infinite loop. It will never end on its own. That's what we just talked about right here. In this example right here, this cout statement will never be false because we have nothing to make this number less than or equal to 5 be false. The while loop is good for data validation. Just like we did for your lab that you're turning in, but you don't have to use a while loop for your miles and segments, but we will use it when you do our tickets. It is good for data validation because you don't know how many times that user is going to enter in bad data. So you want to constantly keep them there until the data is correct. So that's what they're saying here. Input validation is the process of inspecting data that is given to a program as input and determine whether it is valid. When we did it for our in-lab, we just did a single if statement just to practice with writing an if statement. But if they enter the incorrect information again in the if statement, it continues on. So you can simply have the same logic that we wrote, but just change the if to a while, and it will keep them there. Here's a pseudocode. Read an input file. While the input is invalid, display an error message. Read the input again, and while. Here's the same code that you could probably reuse over and over again throughout your forthcoming labs. If any data is invalid, keep them there. Do not allow them to go on. So in case in this example, enter a number less than 10. It keeps, if they enter anything greater than 10, then keep them here. Do not allow them to go on. So I do not have to worry about errors going past that logic, or what we call the impossible rule, because it's impossible for the user to go beyond this code if they enter in a number greater than 10. So I don't have to worry about logic after the fact or anything else. So it's kind of like the impossible rule. It's best to make an error never from happening than it is to fix it after the fact. Put all the code afterwards to handle it. I'm not allowing them to go on. And here's the pseudocode for it. No, I'm sorry, not pseudocode, the flowchart. Is the value invalid? Yes. Display an error message, read it in. Keep them there. You probably notice on some things in UI, on web paging things, when you type in valid data, it will not allow you to submit, or sometimes a button doesn't get enabled. So they're validating the screen before they go on, so they don't have to validate it on the server. So a lot of sometimes code is done on the front end because they don't want that information to be pushed back to the server and do all that processing and find out that the data is incorrect. Here's another example. While team members is less than this and or this, remember we're checking outside the ranges. If it's inside the range, we use an and. So they're using the or to check outside. If the values for min players is less than min players or greater than max, display an error messages and read in the input. So it's going to keep them here until this statement becomes false. Remember with or statements, both of them have to be false for it to exit out. And here's another one down here. So they constantly, every time they do data validation, they're using a while statement. Sometimes you can do data validation with the do while statement because you want to, in this case, initially prompt them for information, but still keep them there if the information is incorrect. A counter is a variable that is incremented or decremented each time a loop repeats. Sometimes you want to keep track of how many times a loop happens. Or in the for loop, you have that index variable that you need to increment to keep track of how many loops it has to base your control logic on. Can be used to execute execution of a loop, also known as a loop variable, like we saw before, that x is greater than or equal to 5, that is a loop control variable. In that case, it must be initialized. Here's an example using square roots with a while loop. Number right here, tab, tab. Here's escape sequencers using tab, tab. They could use this, or they could use the set W command to make it nice. Tabular command, and then increment. Eventually, this is going to be false and exit out. The do while loop is the only post-test loop we have. In general form, notice the difference between a do and do while. You have a do statement right here and a while statement. Do not get this confused with the semicolon with the while statement here. If you have it in a while statement here, this becomes null and void, similar to an if statement. So this is not a syntax error if it's just a single while statement. But a do while statement says, hey, execute me at least once and keep going while this expression is true. Notice the semicolon here. So in this case, do the statements first, so it's at least executed at least once. The expression is tested. If it's true, it enters the statements again. If not, it bombs out and continues on. Here's just a simple example of a cout statement. Do 1, it displays 1 here, while x is less than or equal to 0. It ends, and then that's it. It at least does it once. It's the only post-test loop we have. Here's an example. Enter the scores, score 1, score 2, score 3. It does the average, and it prompts them, would you like to do it again? If they enter yes, lowercase or capital Y, then it goes back up. If they enter anything else, it returns out. So the code is done at least once. Loop always executes at least once. Execute continues as long as the expression is true. Useful for menu-driven applications because once an application starts up, usually the first thing that displays is a menu option. Even though the menu option the user might quit, give the quit command, but it's the first thing that always starts up, so you always display a menu. The for loop is a pre-check we just talked about before. You have the initialization, semicolon, test, semicolon, update, and then the statements that you want to execute. Notice the semicolon between each section. It performs the initialization section only once. Evaluates the test next, and if it's that true, it executes the statements. Then it goes to the update section, and then it runs the test again. If it's still true, it continues the loop, and so forth. Same thing that we saw with the while loop, they use it in the for counter. And we just talked about this before. And the flow chart, everything else is the same. They're just showing you another for loop example because you know the range of how many times it's going to go through, so they're using the for loop. You can still use the while loop, but that's usually what the for is. Especially when you go to the enhanced one or the for each methodology, you would want to use that because that way it knows how much you go through. We already seen that, just re-emphasizing. In any situation that clearly requires an initialization, a false condition to stop the loop, and an update when to use a for loop. Like once again, the for loop is a pre-check. We have 2 pre-checks and 1 post-check. If the initial condition is false, it will never execute. you can have multiple initializations. You can also have multiple updates. Just as anything else, with a list, put a comma. You can also have more complex statements. You can have x less than or equal to 5 and this or this. This could be complex as well. You can still add. You can omit the initialization. Technically, you can omit all sections of it. You can have blank, semicolon, and then blank. But these values and so forth have to be put somewhere else. And we'll do that during the review to practice. But you need, even though if these are blank, you still have to have these semicolons here. But you still have to have some kind of condition test to be. You can declare variables in the initialization expressions. If this int num right here is declared in this for loop like this with the int num, this num is only seen in this for loop itself. It's not seen outside. Unlike this integer sum, it's declared outside, so you can see it inside the loop and outside. So remember, when it comes down to it, you have scope. This shows you keeping a running total. This is probably good for your upcoming labs as well. Running a total is accumulation of sum of numbers. So while you're going through an array or whatever you have these values right here. Sum plus 1, that's constantly being added. And you have your running total and your accumulator. How many times did it go through? Accumulator is a summation, keeps on adding, and the number is how many iterations it does. So running total and accumulator. And that's just a flow chart for that. And here's just an example of a running total. For in count is equal to this, count is less than or equal to days. It's entering the daily sales. Here's your accumulator right there for the sales. And then it displays the information for you. A sentinel is another form of what we call flag. It's a value that's would not be part of the values you're reading in. For example, if you're reading in grades and you don't know how many users are going to enter a grade, you might want to say, hey, user, when you're done executing, type in -999 or -5 to signal the end. But do not take that value, that sentinel, as part of the data being read in. It's kind of like a different form of a flag to say, stop it. Similar to flags, but it doesn't have to be Boolean, true or false, like a flag usually is. It's just usually saying some data that I'm going to read, and when I hit that value, I'm going to stop. But that value that's my stopping value, do not take that into consideration of part of the data to read in. And that's what example right here. While points is not equal to -1, keep reading it in until the user enters a -1. Then enter a -1, it sees -1 is not equal to -1, which would be false. It bombs out, but it never takes that -1 into consideration for the accumulation. Here it goes in, it reads 7, 9, 4, 8, sees this -1, but it doesn't consider that values when it does all the addition. Important slide, deciding which loop to use. Some of these loops you can use interchangeably. I'm not going to grade you on, well, you shouldn't use a while loop compared to when you should use a do while loop and so forth. That is your experience and what you want to do. So the while loop is a condition pretest loop. iterates as long as certain conditions exist. It's used for validating inputs, reading lists of data terminated by a sentinel. The do while loop is the only post-test loop that we have. It executes at least once. It's good for menu-driven programs. It is also can be used for data validation as well, because if you're reading in, let's say, tickets, you're going to always prompt them at least once for the values. So it can be used for data validations as well. For the for loop is a pretest loop. It's built in an expression for initializing, testing, and updating situations where the exact number of iteration is known. We will revisit the for loop using the enhanced for loop, aka the for each loop, in chapter 7. You can nest loops within loops. So for example, you have rows and columns. For each iteration of this for loop, you're going to execute all iterations of this. Once this execute is ended, you're going to go back to the outer for loop, increment the value again, and then redo this all over again. This is usually a good test question in various forms. This was also a test question one time when I was going to an undergrad school, but they made it more complex. Do not allow this logic to confuse you. Know how it works. If this is true, it's going to go all through the loops of this, and then it's going to increment again. If it's still true, it's going to go all through this again. So if you want to know how many times these two execute, it's like finding the volume of like a square. These may do, well, I would better say rectangle because it's different, it could be different sizes. So if you want to know how many times these execute, you would do row times column. How many rows do I have times how many columns do I have? And that will give you the number of times this loop will execute. And one time in my labs, we had to use pointers, but using arrays in a multi-dimensional array. So we'll talk about that when you get to chapter 7. It was a headache to do, but once you understood the concept, it was easy to understand. But first of all, you had to understand the concepts of how these loops work. For example, in this case, for students right here, it enters all this information in. Once it's done, it displays this information out here. It goes back to the top of the for loop and resets all this information again and again. So in this case, the for loop, the inner for loop, is always going to finish first before the outer. Because for each outer loop, all the inner loop has to be executed. The inner loop goes through all repetitions for each repetition of the outer loop. The inner loop repetition completes sooner than the outer. And to find out the number of loops, you do the multiplication. That's what it says. Total number of repetitions for the inner loop is a product of repetition of the two loops. Like addition is a summation, subtraction is a difference, product means multiplication. Using files for data. For everything that we have written in this program right now, each time the program ends, the information is lost. For your next incoming lab, you are going to generate a report. You're going to write to a file. Things sometimes write to a file because you might want to read it back in later. It's the idea of trying to persist the information to another form when the program ends. Can use file instead of keyboard monitoring screens for program input. It's another way of getting information in. Remember, in this course, we'll, for the most part, going to read in values from the keyboard, and we might read it in from a file. So those are the two ways we're going to get input in. It allows data to retain between the program runs, because when the program ends, that file still persists on your hard drive or wherever you've written it to. Use the FString header file. So now we have a new preprocessor. The FString. The FString allows you to create these three different objects. The IFstream is used for input only. It allows you to create an object for input only. The OFstream is for output file. The FStream allows for both input and output to the file. So this is the way you define your variable. You have IFstream, like we normally would have int double string. All this remains the same. And then the name that you want to go with. Same naming conventions as always. This OFstream will create an output file stream and with this variable. Any file, whether it's going to be read to or written to, must be open. Must be open. With that being said, for all your labs that you're going to read or write to a file, always put it on your desktop, and the file will be generated right next to your source code. If you're going to use a virtual cloud, put it on your desktop, because like we were in class, students will sometimes write directly to the thumb drive or another part of their system, and they didn't have permission to it, and so it was giving problems. So when you write your code, always make sure it goes to your desktop. The way you can easily do that is like we did our labs before, and we'll do it again on Monday when we do our next in-lab. Once you create your project on your desktop and you put your source file in, do not put any kind of file path or anything else next to it. Just do something like this: input inventory date.dat, and we'll write the file right next to your source code. That is fine, because when I run your source code, I don't want you to put C:\user so-and-so. That would be an error, and then that would affect your grade. So always make sure your file is right next to your source code, because when I run your source code, that's where I'm going to look. And so that way we don't have problems with permissions. Use the open command member functions to open the file, whether it's used for input, output, or for both. File names may include drives and path info. Do not put it for this class, because your path and my path are most likely going to be different. And if I'm grading your lab and that doesn't generate the report based on whatever matters, it's on you. It affects your grade. So make sure you do not put any file paths or anything else in. Do not put C:\/ or anything. Output file will be created if necessary. Existing file will be erased. So if you're going to create an output file called report.txt, the next time you run it, the information is going to be erased. Input file must exist for open to work. Always test to make sure, hint, 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 always make sure that the test opens and it's open successfully. If it doesn't open successfully, I catch a lot of students on this part right here, that it doesn't open successfully and they catch it, but the trouble is the program still continues on and tries to write to that file. So be cautious of that. So in this case, the person right here is saying input file, open file, test.txt. If it's not open successfully, notice the unary operator right here says A, file open failure. There's also a command that you can use for fail member as well. It's called infile.fail, I think. I have to go look it back up because I don't use it for C++ that much. When you write data to a file, it is exactly like the cout construction. When in class, when you do it, I usually do not put the cout file right away. I usually put this as cout, make it look all good on the monitor, and then I change all my cout statements to the output file. That way it saves me time, so I don't have to go back and forth of opening the file and closing it, opening the file and closing it. I display it all correctly on the screen with the cout. Then when I'm done, change all the couts to the output file. So the same way. And when you read in data from a file, it's going to start from the very beginning, and it's going to be like a file pointer. It's going to go through, and it's going to say, hey, I'm going to read in, if this is a string, I'm going to read in the first string and put it here. Whatever the quantity in stock, if this is an integer, it's going to assume the next part to part num is integer. So when you read in files, you have to know the layout of the file. I have come many times when I work in the pharmacy and I'm doing drug inventory, and we agree on a standard with a third party saying they're going to give me a flat file which says the first part's going to be the indice, the next part's going to be the quantity, then it's going to have a sentinel value like of a pipe symbol, then it's going to be the next drug, and so forth. And we have to agree on that standard because that's the way I'm going to read in. If that is breaks because he adds something else, then we're going to argue back and forth. So for reading in files in this way, you must agree to a standard. So you have to know the layout of how the file looks when you read it in. The stream extract operator returns true when a value was successfully read in and false otherwise. So right here, as you read in, correctly read in the input file, it assigns its number. If it's successful, it keeps on going, and it keeps on reading the next one in. Always, if you open something, close it. That's another thing I watch out for. A lot of things, if you don't know, when you try to use Word or you try to open up another file, it says that the file's already been opened, or you try to close something and it hangs there. A lot of that's part of resource management. Always, if you open something, close it. We have come across a lot of times at one of my jobs where they had memory leaks because someone opened up a connection to a database and they didn't close it. You usually have a connection pool of how many connections you can have open at one time. And if some code doesn't release that connection, it's a memory leak. Because now that connection cannot be reused. Same thing with files. You can only have so many open files. So be careful to make sure every time you open something, you close it. Don't wait for the operating system files at the program end, because if the operating system closes it abruptly, not all the information could be written to the file. Garbage could be written to the file. So be careful. And so don't wait for the operating system to close the files at the program's end. Maybe limit to the number of files open. Yes, same thing with the database. And maybe buffered output data waiting to be sent. So sometimes writing to files is a big memory hit, just like kind of like the old gaming systems where they had to read back from a hard drive or read from a CD-ROM. You have that lag. It's a big performance hit to sometimes read information from files. So that's why sometimes they do buffering. They read so much in, they write so much at a certain time. So if you wait for the operating system to close it, that information may or may not have time to be written to that file. So it's always wants to make sure that you close it. In many cases, you will want the user to specify the name of the file. In C++, you can pass the string object as an argument to it. So you can enter the user information in the file. Do not do this for your labs. You can do it for your lab 6, but this is, remember, case sensitive. So if I type something in that's different or trying to open up something, it will not find it. That's why a lot of UI work users, when they do UI interface, they do not make you type in the name. You get the dialog and you find it. So do not necessarily do this. You can hard code your files for this class because I'm not testing whether you can find it or not. I want to know, can you read and write to a file? Here's an example right here. They enter information into a file. They open it. You can see right here, when it's input file right here, it's reading input only. Notice they have the preprocessor directive FString right here. When it opens in, if the file is opened successfully, it does its work. Notice it else. It doesn't have anything, it doesn't just simply have the if. All the logic is whether it's opened successfully. While input is equal to numbers and it reads it in, it displays it out. It goes back up here, reads another one, displays it out. Eventually, this is not going to have a successful read. It's going to return false, and it's going to exit out. Know about this. I'm not going to quiz you or test you on it. This was an old issue with the old C, and it came up when I first started teaching this class. Using the C_string member function in older version of C++. I think we're past version 11. I don't know what version we're on. But you would need to use this C-string object converter to be able to pass it. So you would take your string object and do C-string. Just be familiar with it, like we did with the class name. In the previous one right here, when you typed it in, you would have to, go ahead. Did someone say something? No. You would have to use a file name .cstring. We're on the newer version, so you do not need to worry about this. But in the real world, you might have some old legacy code that you might see, and that's what they still have the slide in for. So the two ways that we can exit the loop prior to just a normal condition being false is using a break and a continue. They are handled differently. Can use a break to terminate execution of a loop. Use sparingly, if at all, because it makes code harder to understand. When used in an inner loop, it terminates the outer loop. So, for example, while loop, I just said true. If condition, let me do it, it's greater than 0. Yeah, that's fine. X is less than 10. X is equal to 5. Break. Can everyone see that code right here?
Yes.
In this case, where's my mouse? X is equal to 10. X is less than 10. Oops, but let me do this. So X is 0, X is less than 10. So it's going to go inside this loop. Eventually, it's going to equal, X is going to be 5, and it's going to break out of the loop. So it's going to end. Everyone understands that concept, right? I break out of the loop. With that being said, why they say it gets confusing and used sparingly, because now I have two ways to exit the loop. I can have this part right here, which eventually will become false, or I have this way it exits. So I have potentially one way in, two ways out. However, now I have a while loop inside a while loop. We call these nesting loops. Same thing with if statements. But now, when this break right here is reached, it doesn't end here. It ends only here. It only breaks the current loop I'm in. Got it? However, if you use an exit, that exits the entire program. But that's why they said use sparingly. Break only breaks out the current loop that you're in. With that being said, let's take this part off. And then the other one that we could briefly talk about is the continue. The continue is different. Think of it as a question mark. As we go through this, x is eventually going to be 5, and it says continue. All continue says to do is go back and reevaluate me. Go reevaluate. Reevaluate. If this is true, still true, continue on. If it's false, then exit out of the current loop that I'm in. Not all the way out, just the loop that I'm in. So if it's still nested, it only breaks out of the nested one. And that's what they're going to show right here. Play from the current slide. Can use a break loop to terminate the execution of a loop. I wanted to show you what it looks like in code so you can see it. Use sparingly, if at all, makes code harder to read. That way you have one way in, two way outs of your loop, which is sometimes bad. I'm going to say sometimes, it depends on the performance and what you wanted to do. When using an inner loop, it terminates that loop only and goes back to the outer loop. So it only breaks in, if you're in the inner, it only breaks the loop that you're in, the inner loop. It doesn't break it out. The continue is what we just talked about. Think of it as a question. Do I need to continue by going to reevaluate yourself? Can you continue to go to the end of the loop and prepare for the next loop? While the do while loops go test, repeat, loop for the rest. For loop, performs, updates, tests, and then repeats. Same thing, use sparingly. That's all it says. With that being said, do not put code right after this. So if you have curly braces here, and you have a continue or a break, no code here. Because if you have code, the compiler is going to usually hiccup on you to say this is AKA dead code or unreachable. Because whatever you do, if you break here, it exits out the loop. If you hit continue, it's going to go back. So it's never going to hit the code directly after the continue in this case.
Can you give an example of why you'd want to use continue?
No, because I never really use it. Break, I have. Break, I have. Not right tip of my head right now. No, I cannot think of, unless it's maybe a condition that you would maybe want to prompt the user for input or conditional to say, hey, I'm calculating this, would you like to continue? And you prompt them again. Probably getting additional information. But most of the time, I don't see a need for the continue. I have never coded a continue. I have coded a break before for performance reasons, because if you're searching a big list and you want to see if occurrence had happened, you would write a break sometimes to exit out, especially if you're using a polling language where the language where someone would set this one always be true. Then the only way that this can be getting out would be a break. So it all depends. No, I can't think of a reason for a continue right off the tip of my head. No. But any other questions?
No.
So we talked about a lot on this one, but it's a simple concepts: increment, decrement, and the 3 types loops and file processing. With that being said, the tail part of it is, what's your next lab? Here is your next lab. Use the topics we learned in class. Some students have more experience and they want to use arrays and so forth. That is helpful, but only use the topics that we discussed in this class up to this point. Write a program that calculates the occupancy rate of a hotel. The program should start by asking the user how many floors the hotel has. A loop should then iterate once for each floor. In each iteration, the loop should ask the user for the input of rooms on the floor and how many of them are occupied. I'm not asking for occupied and unoccupied because you can calculate that. The program should output a file called hotelreport.txt, and it should display neatly. I do not care the formatting of it. Think of you as a boss. How would you want to see this report? And inside the report, you must tell me how many rooms the hotel has, how many rooms per floor are occupied and not occupied. Remember, you're not prompting for the not occupied, you're only prompting the user for how many occupied. The total overall rooms that are occupied and unoccupied. So you got the cumulative for both. And the percentage of rooms that are occupied. Not necessarily per floor, that's for the entire hotel. For those that do not know math, I put the calculation right here. The percentage may be calculated by dividing the total number of rooms occupied by the total number of rooms. Think of you as a CEO. How would you want the report to look? Also include validation. Remember, a floor may have 0 floors. I've seen some in like New York and so forth where it's just the lobby where you check in and then you have to go up and down. So 0 is a valid value for that floor. Not only that, you also have to validate for negative values and also when you have occupied and not occupied. So if the floor has 10 rooms, the number of occupied cannot exceed 10. Or can it be a negative number? So such as data validations are but not limited to when entering the number of rooms or how many are occupied. Negative numbers should not be allowed. In addition, if the user enters a negative number, program should not be allow the user to proceed until the data is correct. Any questions on this lab?
No.
I would recommend, do not worry about file processing at the beginning part of it. Display everything to the screen, get your data validations done, and then do it. But do not do a loop first. I would recommend doing a single pass through with no loops, grabbing the input, do your data validations, and then add your looping to it. Take it incremental approach. Do not try to do all the looping and data validations at one time. Break it apart. Do step by step. I've seen students that try to write it all at once and try to debug it, and it gets confusing. Do it incrementally approach. Any other questions or concerns? I will stop the video, well, at least stop screen sharing. Any other questions? You have your labs due tonight. You also have your quizzes done. Need to be done in 14 minutes. Any questions for this chapter or the upcoming lab? I recommend you get started on it sooner. Yes, did someone speak up? If you're good, let me see if there's any questions from the messages. Sorry about the last loop. Okay, if anyone else is good, you're free to go. I'm not going to keep you any longer. Have a great night. If you have questions, I will stay on.